Data science is a broad field that encompasses a variety of practices aimed at getting value from data. Examples of practices that fall under the data science umbrella include data pipeline design, data visualization, data wrangling, machine learning, statistics, etc. Machine learning. That is a very powerful and popular field within data science. Machine learning can also be considered a subfield of artificial intelligence. Some phrases that are typically used in the context of machine learning are pattern recognition, predictive analytics, predictive algorithms, computational statistics, etc. So, what exactly is machine learning? In a nutshell, machine learning is the specific practice of using mathematical algorithms that consume data, learn patterns in that data, and then use those patterns to make predictions. Let's imagine a simple example to describe how machine learning works. Suppose we want to predict the sales of a given product over the next quarter. We might know that the sales of this product are sensitive to how much money we spend advertising the product. So we go back and look at many historical business quarters, and for each of these historical quarters, we know how much money we have spent advertising and what were our sales. Okay, so if we make a plot of this data, it is obvious that more money we spend advertising, the more we will sell the product. If we want to predict our sales revenue during the next business quarter, then first we fit a function to our historic data. Then we find out how much money we have budget to spend in advertising during the next business quarter. Now it's just a matter of evaluating the function we fit to our data at the value corresponding to advertising spend for the next quarter. So, from a data perspective, the problem is reduced to compiling a table with historic data. We have one column in the table representing what we want to predict, which in our example was sales. In the language of machine learning, this column is called as target. The other columns are called the feature columns or just features or drivers and are used to predict the values of the target column. This is the fundamental idea behind machine learning. Given a data table, we find a function that fits that data so that we can predict what the value of the target column will be given values for the feature columns. I hope that's clear. Over the years, the entire families of sophisticated machine learning algorithms have been developed to excel at different kinds of applications. But fundamentally, all of these algorithms are doing the same thing. They consume a data table, they learn patterns in that data to predict what the target column will be, given the values of the feature columns, and they use that to make predictions on the new data in the future. It is important to keep in mind that the algorithms are learning patterns in the data we feed them. When we feed data to a machine learning algorithm and let it learn those patterns, we say we are training a machine learning algorithm. Keep in mind that once we have trained a machine learning algorithm and use it to make predictions on future data, we are working under the assumption that the data we are making predictions on is similar to the data with which we trained our algorithm. Imagining another example, let's say we want to predict something which is not a number. Say we have recorded data around a large sample of iris flowers. For each flower, we have recorded the length and width of their petals and sepals, as well as the kind of species of iris it belongs to. In the future, when we encounter a new iris flower, We would like to be able to predict what kind of iris species it is based on its sepal length, sepal width, petal length, petal width. We can feed this data to a machine learning algorithm that fits a function to the historic data. Such a function would output a species type based on the values for the other four variables. Here, the output is a category from a discrete set of categories. These problems, where the target column is a categorical column as opposed to a numerical column, are called as classification problems. Problems like in the sales example we have just discussed, that is, the problems with numerical target columns are called as regression problems. The examples we have talked about involves training a machine learning algorithm to predict values for a target column using the values of the feature columns. We should note here that there are other types of machine learning problems that do not involve a target column. Here, the algorithm only takes the rows of features and then tries to get some insight out of those features. A common example is clustering all the rows of data into meaningful groups. Problems where we do not have a target column are called as unsupervised learning problems. In AutoML, we will only focus on problems where we have a feature column and a target column. And these problems are called as supervised learning problems. So I hope this whole introduction of machine learning was useful to you in understanding how will the AutoML work and what exactly are we doing using the machine learning algorithms that Click AutoML will generate automatically for us.